Hello friends, let's take the problem of spring. First problem of spring, a helical compression spring neglecting the stress concentration, neglecting the stress due to the curvature of the wire. This is the first problem on helical spring. First problem we have to design a helical compression spring. It is made up of alloy steel and following are the specification of the spring. The mean diameter of the spring is 50 mm, wire diameter is 5 mm, number of active coils is 20. Given data is written, given data is D is equal to 50 mm, D is equal to 5 mm, N is equal to 20 and the load applied on the spring is 500 Newton. For calculating what is asked in the problem, if the spring is subjected to the axial load of 500 Newton, calculate the maximum shear stress which is induced in the spring. This is the formula for the shear stress induced in the spring. Ks is equal to 8 WD upon pi d cube. यहाँ आपने याद रखना है फॉर्मूले खाली पहले याद कर लो. What is formula? This is a universal formula which is used to calculate the shear stress induced in a spring. The first formula is neglecting the curvature effect, and neglecting the curvature effect, the 1 plus 1 upon 2c is the stress formula, shear stress factor formula. By putting the value we get we get the shear stress in Newton per mm square. What is Ks? Ks is equal to 1 plus 1 upon 2c 8 Wt upon pi d cube. Therefore, putting the value, देखो 1 upon 2c, c is given. What is given? The c is calculated by the d is the diameter of the coil and d is the diameter of wire. By putting this value, we calculate the shear stress induced in the spring. The another is problem number 2. A closed coil helical spring is made up of 10 mm steel wire. A spring consists of 10 complete turns into mean diameter of 120 mm. This is spring consists of 10 complete turns. 10 complete turns, n is given 10. Mean diameter is 120 mm. The spring carries an axial load of 200 Newton. Determine the shear stress induced in the spring, neglecting the effect of stress concentration factor. Determine the deflection in the spring, stiffness, strain energy stored in the spring. You have आपको याद रखो कि फॉर्मूले पूरे याद करना है. This is the formula for shear stress induced in the spring. Shear stress induced in the spring. This is the formula for the shear stress induced in the spring. This is the formula for deflection induced in the spring. Stiffness is given by the load upon deflection and strain energy stored in the spring is given by 1 by 2 W deflection. First three problem are very important. The third problem is of design a helical spring due to the curvature of wire. Third problem, a helical spring is made up of wire of 8 mm diameter and has an outside diameter of 90 mm. If the permissible stress induced in the spring is 350 Newton per mm square and the modulus of rigidity is 84 kN per mm, find the axial load which the spring can carry and the deflection per unit turn. Right? This is the given. D is the diameter. D is the 90 mm. Shear stress induced in the spring is 350 Newton per mm square. G is the modulus of rigidity 84 kN per mm square. First is calculate the first we have to calculate spring index. C is equal to D by D. If we have given the outside diameter we have to calculate the mean diameter. This is the formula for calculating the mean diameter of the spring, DO minus D, right? Then you calculate the spring, this is the diameter of coil, this is the diameter of wire, neglecting the curvature, effect of curvature, neglecting the effect 1 plus 1 upon 2C, calculate the shear stress and deflection per unit. And using the effect of curvature, the Wahl's correction factor is used, where we have calculated the 4C minus 1, 4C minus 4, 0.615 upon C. By this formula, you can calculate the shear stress factor. Here K value is you put 1.14 1.1411 and calculate the deflection and the deflection per unit turn. This is the deflection per unit turn, and this is the load which is applied on the spring using the Wahl's correction factor. Thank you, friends, for these three. First you have to solve first three problem, and then we will start for the next problem number 4 and in the next video. Thank you, friends. You keep in mind that the only the formula which is given in the PDF, you first solve that and solve the problem. First three problem is very important, and first three problem is always asked in the exam. Thank you, friends.